Alright, we are looking at infinite limits. And the first one we're going to look at here, f of x is equal to 1 over x. If I were to plug 0 into this function, because 0 is in the denominator, right, this thing is undefined at 0. But so that doesn't tell us what's happening to the graph, either on the right hand side of 0 or on the left hand side of 0. So what we're going to do to find out what the behavior of the graph is doing is we're going to use the limit to find this out. And if I took the limit of 1 over x as x approaches 0, well, that limit does not exist. And of course, this is not just an equal sign here, right? I've got these two little dots. We all know what they're called, but anyway. So this right here, I'm just saying, hey, look, this limit does not exist. Here's the graph over here of what 1 over x looks like. All right, what 1 over x looks like. But let's kind of look at this coming in from the left and from the right and seeing what we can tell about this graph. Let's say we didn't have a picture to look at. So what I'm going to do here is I'm going to come in from the left-hand side, and I claim that it's going to negative infinity. Now remember, this is not an equal sign here. So your limit, even though in some textbooks you'll see the limit, you'll see an equal sign and an infinity symbol, but technically remember our limit either doesn't exist or it's equal to a real number, and that's not a real number. Alright, well, I claim that coming in from the left it's negative infinity, and coming in from the right hand side at 0, remember that's what the plus is up here, it's positive infinity. And the way we can do this is we can do this numerically, and this is the way I encourage everybody to do it numerically to kind of see what's going on here, where these things are actually going. So if I come in from let's see, I do the right here first. If I come in from the right at 0, so we get close to 0 from the right hand side, I take 0.1, I plug it in here, and I get 10. Well, that's a positive number. And then I plug in 0.01, so that means we're getting closer to 0, and we get 100, and I do a third time 0.001, getting closer and closer to 0, right? And I'm getting 1,000. So that's a good indication. All these values here are positive, and you notice that they're increasing pretty fast here. But that's an indication that this thing is increasing and it's going up. So that's the reason this is a positive infinity right here, positive infinity. All right. And then we come in from the left hand side, so it's going to be a negative 0.1, I get a negative 10, negative 0.01, I get a negative 100, negative 0.001, right? I get a negative 1,000 over here, which is off the screen. That's okay. So this tells us that it's going to negative infinity. All right, it's going to negative because these here are all negative values. Right, so we could actually just kind of look at this and go, okay, if I plug in a negative number, right, the whole thing's going to be negative. And so you see what I'm saying? So anyway, and if you plug in a positive number, this is going to be positive. That's kind of a quick way of looking at it. And then there's this thing called the vertical asymptote, which up to this point in your math career, you should have already talked about vertical asymptotes in an algebra class, but we're going to go over vertical asymptotes and how they're different from actually finding the limit as x approaches 0. But this just kind of helps you actually find that vertical asymptote, but this is doing it with limits here. So the limit is going to, remember, tell us, it gives us a description of what's going on with the graph, the actual behavior of the graph.